Hi, my name is Darrell Moffat, and I'm part of the Animex International team alongside my colleague Kelly Clark. Today, we want to share with you some of our projects we're working on to reconnect Dormouse habitat. If you haven't heard of us, we're a company who specialize in wildlife mitigation. Our background is in ecology, but we've combined this with engineering techniques to create solutions that actually work for wildlife. We're based down in Hampshire, but we work all over the globe doing wildlife mitigation, especially across roads and other transportation infrastructure. We cover a broad range of aspects, including wildlife fencing to lead animals to crossings, bridges, animal detection and warning systems, and creating technology and guidance in partnership with researchers and governments. Within the UK, our main work includes a Dormouse bridge we've developed together with PTES and our new habitat highway to create habitat connectivity units across infrastructure. And these are the two aspects we're going to be sharing with you today. We're also working with the Wildlife Trust and National Highways on studies that focus on creating more green bridges and connectivity across infrastructure for wildlife. So first, I'll be discussing the Dormouse Bridge, and then my colleague Steve will take over and talk about our new habitat highway, both of which can help provide connectivity for dormice. To give you some background, we partnered with the People's Trust for Endangered Species in 2015 after hearing about the idea of the bridge. We wanted to make sure a design would work before it starts being used on projects, so we started off with a trial. The bridge design was based off a similar Japanese design with the behavior of dormice in mind. There's multiple entry points and options they can climb on, as well as shelters along the bridge to help them feel secure. The bridge was monitored over a full active dormouse season, and dormice were found on the bridge the first time only 9 hours after it was installed, and they showed a preference for using the bridge over crossing on the ground. This research was published in Conservation Evidence in 2019. In addition to dormice, red squirrels also frequently use the bridge. We wanted to be able to apply this design to real projects, but here in the UK, road safety standards are extremely high. We met with highways engineers to upgrade the design for compliance. We changed to longer lasting materials with the aim of keeping it as similar a design to what was tested. We did also replace the trial bridge on the Isle of Wight with an upgraded prototype and found dormice were still using it in the last year of monitoring in 2019. Two overall installation methods were also developed: the standalone bridge, which is installed independently, and the retrofit bridge, which is attached to existing infrastructure and more suitable for longer distances. Two different shapes were also developed: the classic triangle, like in the trial, and a stronger square shape as well. Now, I'd like to share a few projects we've worked on and what we've learned from some of these projects. So the first project I want to talk to you about is the M1 Smart Motorway, because it was our first bridge across major infrastructure. As part of this project, two Dormouse bridges were proposed as mitigation to reconnect habitat at over 75 meters length each. At these lengths, a retrofit bridge is the only option, so two existing infrastructure were chosen to connect the habitat either side. One of these was a bridge overpass, and the other was an underpass, both of which were used as farm access roads. There were a number of constraints that made this project a little bit more challenging than our previous ones. First is that this project had a limited timeline, so they wanted to keep the technical approval category to the lowest possible. But at the same time, this is a major motorway with extremely high safety standards. Multiple stakeholders were also involved, each giving different perspectives of feedback on the designs. Other constraints were the location and the space itself. These roads had public access, so the risk of vandalism had to be considered, and the infrastructure still had to be used as the farm access it's intended for. So in the end, this project did get completed with only an 8-month turnaround, but the challenges we met also really influenced our standard of design on all our future projects. So we improved the materials, we now fix everything on the bridge with secured bolts, and we worked with the engineers to create new installation methods that really consider all the needs of the project. So this project really pushed forward the technical aspects of our bridge. Another project I want to share is a standalone bridge that was installed on an access road in Denmark in 2022. This one's a good example because it shows how the standalone bridge works, supported by large posts on either end. For this project, the engineering works had to be adapted for international standards. As well, you can see in the photos here how the bridge ends temporarily connect into the habitat. On many mitigation projects for new infrastructure, they've removed quite a bit of habitat, so it needs planting up after the bridge is installed. On this one, you can see they piled brash and directed the tree branches into the bridge ends, and that's to provide temporary connectivity for the dormice. Ideally, it's planted up right away with fast-growing scrub. Species particularly like bramble, hawthorn, and blackthorn are good. And these species are good both because they keep people away from the ends because of all the thorns, and they also provide really good connectivity and dense protection for the dormice around the bridge ends. Now, the last project I want to share with you today is a residential development in Wales. So this site has 2 standalone bridges with a third planned for the future. Residential developments are finding an increasing need for maintaining dormouse connectivity because they're often cutting through hedgerows or tree lines to get the road access onto their site. With early planning, the bridge can be incorporated into the site design in the best locations within the site. So that's something we work with the developers to help select the most appropriate areas for the dormice. As you can see in the photos, this one does need some major planting on the one end, and that's going to be included into a green corridor here for the site. But the idea is once it's all completed, all the planting's done, and the development's fully finished, it's going to maintain that connectivity so the populations aren't permanently separated by the road. So we decided to compile everything we've learned over the years into a new best practice guidance. This is available on our website, and it summarizes the entire process in detail, right from the planning stages all the way through to the post-installation monitoring of the dormouse population. We chose to include the technical aspects as well in the planning. The technical aspects affect how the projects get implemented, and so I think it's really important to look at all the aspects of the project to make sure it's successful. Now that I've given an overview on the Dormouse Bridge, my colleague Kelly will share our newest project called the Habitat Highway.
Animex International are excited to introduce the Habitat Highway. The Habitat Highway instantly transforms urban infrastructure such as underpasses and overpasses to provide vital landscape connectivity for wildlife by reducing fragmentation. This modular system has been designed to be adaptable and easily deployable. Each of the modules can be connected together to provide fully customizable layouts for any existing structure. Each module is fitted with an internal irrigation system and rainwater harvesting tray so that minimal maintenance is required. Native wildflowers, grasses, shrubs, and even trees can be planted to blend seamlessly with any natural environment, enhance biodiversity, and even contribute towards carbon capture. Although roads are an integral part of modern life, they can have a negative impact on wildlife and biodiversity. The construction of new roads leads to habitat loss and fragmentation, which prevents wildlife from moving around the wider landscape. Collisions between vehicles and wildlife can result in the direct loss of individuals and also pose a risk to human life when vehicles collide with large mammals such as deer. On top of this, there is a huge monetary cost involved in repairing the damages caused by these incidents. Did you know there are over 250,000 miles of road across the UK? Each year, a staggering number of animals are killed in wildlife vehicle collisions, and the numbers you are seeing on the screen here only account for the UK. We are using the Habitat Highway on a project in Hampshire that will enhance two disused bridges over the M27. This project will reconnect the landscape and allow wildlife to move freely between Swanwick Nature Reserve to the north and the woodland at the Burston Brickworks Heritage Site to the south. But where do we go from here? Our ambition is to deploy 500 habitat highways across overpasses, underpasses, and alongside roads in the UK. We are currently working in partnership with the Devon Wildlife Trust on the Network for Nature scheme to assess suitable structures across the Devon County and are excited to see how this project progresses. But that's not the end. We would like to hear from you. Do you know of any locations where the Habitat Highway could reconnect the landscape and support our British wildlife? Thank you for listening to this presentation. Please come and talk to our representatives on the stand and don't forget to grab your free stickers whilst you're here.